So this is going to be a brief introduction into using the GitHub repository and Paperspace and how to set up a machine and a job, which is basically one of your experiments. So first thing we're gonna do is we go into Paperspace, we select gradient, which is the machines that we're using for neural network applications in Paperspace. And we're going to run a Jupyter notebook, yeah? To do this, first thing we need to do is create a notebook. We're basically selecting a machine and then using this machine to run our code on the cloud. So I have a bunch of already like a ton of different notebooks you see here. You probably have none, but these are for different experiments. But you see on the right side, there is a green button called Create Notebook. Yeah. And that's the first thing you're going to do is you're going to create a notebook. And from the containers that we're using here, we're going to use the fast.ai container. Yeah. And you see that they have different prices, right? And the ones that are useful for what we're doing here in the course are the P4000, P5000, P6000. These ones are really good. And I'm going to start with this 8 CPU machine here, a P4000. This is sufficient for the first test that we're going to do now. If you're doing, for example, images with larger resolution or more complex applications, you can, for example, try a P4000, and if it takes too long or it's problematic, then you can switch to a P5000 or a P6000. Yeah. Also, make sure that the notebook is placed in the following storage region. Normally, for everyone who's sitting on the East Coast, it's going to be the East Coast automatically. I guess that Joy will have a West Coast machine coming up. And when you're sitting if you're in China, yeah, this could be a bit problematic. You can try to run Paperspace using a VPN. This normally works. It might be a bit slower than usual, but it works. Yeah. So you can use the East Coast machines for ones that are on the East Coast. I habitually set this time low. So it's actually auto shutdown is normally on 12 hours. Yeah. I normally put it, I mean, when I'm really working, I put it to 6 hours. Today, I'm just going to put it to 2 hours. Yeah, because it shouldn't be longer than that for now. Yeah. You can leave those workspaces and so on as is. Don't change anything on this here. Yeah. And we're going to create the notebook. Now it's starting to spool up this machine. So you see here now my notebook. I see already, others are already coming up too. Christopher, Jungian, you already are spooling up a machine. That's good. We have to wait for a second now until the machine has really started to work. Yeah, so you see now it's actually opening. Yeah, and it will. So if you go to the status line here, let me point this out here quickly. Use the status line. Yeah, it shows you that it's provisioned. So basically, you're asking now the cloud computing solution. You're knocking on the door and saying, "Hey, I need a computer. Which one is free? Do you have one?" So negotiating basically which machine you're gonna get. Also, one thing: if a lot of people are using the same machines at the same time, so there's a limit of those machines. It's not an endless amount of machines. Yeah. So if you, for example, hit the problem that all machines are occupied, this can happen. You just switch over to a P5000 or to a P6000 machine and just take another machine. Normally that shouldn't be too much of a problem. Okay, where am I? I'm here. It's still provisioned. It takes 2-3 minutes normally for a machine to spool up. It's basically booting up, making the connections, making sure everything's fine. Normally it's also looking for if you have already jobs set up so that it knows that the jobs that you have already in your storage are going to run also on that machine.
Marius?
Yes?
I have an easier here of choosing the machine. The P400 one, it asked me to add a card to unlock the machine and otherwise I
Yes.
can't select it. So is there?
Okay. Yes.
But
Let me point this out. Look, please, here on the lower left. If this here, yeah, if you're at the team or if you are on your own account.
Okay.
How do we log into the team account?
You have been invited by me last week to the team. Every one of you.
If you click like the little gear icon, I did the same thing. I messed up. Like if you click that, you can then hit like switch teams and then you just accept the invite, because I couldn't find it either at first.
So for example, if I go to if I hover over the team, you will see there's several different accounts here. Yeah, there's the teacup account, there's my private account. Yeah, so you have to make sure that you are in your account.
Yeah, I got it.
Okay, good. And I see here, for example, all the people who are in this team. Yeah. Let me go back to the notebooks. All right, so my notebook, where is it now? I just saw it that it was here. So there's several machines already running here. I see that. Yeah. So Union's machine is running, Christopher's machine is running, and my own machine is also running. You can rename them, of course. Yeah. Let's say 2D test or something like this, so you know which machine it is. Yeah. And you see already how long it's running, which is important in terms of how it's actually counting down in the account. And now, when you go to the very right here of your machine, you will see that there's a couple of buttons. One says stop, the other one says open the V1, and open the V2 and share. For us, the important buttons here are open and stop for now. The rest we don't have to care about at the moment. Okay. So let's go ahead and click on the open. Did every one of you download the folder that I shared with you? If you open that folder, you should see in there a file called imagenet-vgg-verydeep-19.mat. Yeah, you see that? It's quite big. It's about 510 MB.
Can you say that one more time?
In the Paperspace training folder that you downloaded, there are anyways there's just two files in there. When I open my machine, I see, you should also see this here. Yeah, you see like a folder called course, V4, datasets, fastbook, and storage, right? Yeah. And storage is the one we're interested in too. So click on storage, yeah. And you see that I already have that file in here. ImageNet-VGG-VeryDeep-19. You have to upload it to your machine so that you're able to run the Python code that we have stored in the GitHub repository. In order to upload this, there's two ways to upload this. I will only rely on the simpler one, which is uploading directly from the interface in Paperspace. The other option would be to use actually the terminal and code a couple of lines of code that allows you to find that file online and load it from online. But we're gonna just upload it from our desktop. So in order to upload that file, you have to go to the upper right here, and you see here that it says, more specifically here, upload. Click on that upload button, and it will ask you, now you have to go to the file, ImageNet-VGG-verydeep-19, yeah, and then just open.
I'm uploading right now.
Okay, I'm repeating it, so just to make sure you figured it. So first of all, let's go to the notebooks. So in the notebooks, you will always find your notebooks. This is this line here. Yeah, you will always find the notebooks here on the left side. It's also here where you can find your jobs. These are the most important parts for us for now. Yeah, notebooks and jobs. So if you click on the notebooks, tab, you see all the notebooks that our group are currently running. Yeah. And you should find your notebook in here too. So I actually called mine 2D test here, 2D test. And it's running. So make sure it's running. Once it's running, you can click on open. And when you open the Jupyter, you see what's inside your machine right now. So it's the course, the data sets, the fastbook, and the storage. And we're interested in the storage. So click on the storage, and you see here that there is already that ImageNet VGG very deep 19 met. I have actually 2 of them. I think I can probably delete one of those, but I'm just going to keep the one here. And if you want to upload this file to the storage area of your machine, you have to go to this button on the upper right here called Upload. Click on Upload, and then you go to your folder that you downloaded from our shared drive, Google Drive. And there's the ImageNet-VGG-very deep-19. And then you click on Open, and it will start to upload it to your storage folder on your Paperspace account. So if you have that mat file, that's basically the file you need to start communicating with anything else. But it's anyways good to have it on record, because anyone who's starting new or alone might be necessary to do it anyways. Good. Yes, so let's go back now to, once we have that file up and so on, let's go back to the model zoo here in GitHub, where we stopped before. I was just trying to make that before we go into the GitHub, so that we have that. It needs time to upload because it's 500 something MB. I know it doesn't sound like much, but sometimes the connection to Paperspace is a bit slow. You see in the model zoo, there's a, do you see that GitHub repository? Yes? Okay. So you see the model zoo is a collection of deep learning models. Yeah. And we have an attention gun, neuron-based deep dreaming, class-based deep dreaming, 2D neural style transfer, 2D to 3D deep dreaming, 2D to 3D style transfer, vertex optimization, pix to pix, cycle GAN, PG GAN. So there's like a whole series of them now in our GitHub repository. The GitHub repository is a work in progress. So we're adding new learning models over time. When we find new ones that are interesting, or when students find new ones that are interesting, they're added to the model zoo. And if you look into this line, what you're going to do today is the 2D neural style transfer. So click on this one, 2D neural style transfer. And here you have like a complete manual of how to use that in Paperspace, yeah, and how to run a 2D style transfer. So we created, like, the first thing we did is create a notebook, yeah, with the web GUI from Paperspace. We uploaded the VGG file, yeah, that's exactly this one here, ImageNet-VGG.net to storage, yeah. And I will share with you now also on the drive 2 images that we're going to use to experiment a little bit around with. Yeah, so I'm going to go back here to the Paperspace account. Let me add those images. So we're going to take. Okay, so if you go back to the drive that we shared, you will see there's 2 images now. MDC pattern 14 and Detroit 1536. Yeah. One is a pattern that I created in Maya a couple of time ago, and the other one is a satellite image of Detroit. Download them to your desktop, please. Good. Once we have them here and you downloaded them, I go back to Paperspace. Rosa, yes, about the maximum number of notebooks. Thank you for pointing that out. That seems to be really an issue. We're trying to resolve that with Paperspace to have more machines on these accounts. Yeah, sorry for that. Well, it's recorded. I hope you can just follow up another time and make some notes maybe of what we're discussing. It's not that complicated, so it should be okay if you try it again later or at another day when you have time. So download these 2 images. We're gonna go back to our Paperspace. Next thing we need to do is, like we uploaded the DGG file, we need to upload the images into the right folder so that the code will find those images, okay? So I'm gonna go back to my machine here, the notebook, and remember on the right side, you type on the open button. This is this purple bluish gradient button here. And in my Jupyter, there is again the same 4 folders, and we need to go to storage. And in the storage, you will see there's like a variety of other things going on here. It's probably much more folders than you have right now in there. But I have also folders for 2D models and 3D models and a variety of other things. The important point here, also this unzip file and zip files are useful for certain things, but I think for today we don't need them necessarily. But what is important is the styles folder here. And in this style folder is where I can upload the images that we just downloaded. They definitely have to be in the styles folder because otherwise the code doesn't find them, okay? And then we just don't, the whole thing doesn't work. Okay, then I'm gonna upload it and we're gonna do a little experiment and see if every one of you sees it, okay? I had to show this anyways, how it works, because if I'm not logged in, you don't see the images either. So, and if you run your machine alone, so you would have to upload it anyways. I think at least, not 100% sure, but we can also experiment around with that. In any case, how this works is that you go again to the upload button on the upper right. And I'm gonna go to the images. So I have the Detroit file here. 1536 just says how big that image is. Oh, I already have it. Okay, get it? So it's already here. Detroit 1, 1536. Yeah. And let's say if I have the pattern already here. Pattern, let me use this one, 14. Yes, it's also already there. Okay, great. So you don't have, well, it's there already. So if it's there, then you probably have it already too. And these are the 2 ones we're gonna use for the next steps, yeah. I would recommend, just as a side note, just to make things a little bit simpler, is to, this is the image, just if you click on it, you can basically see it. Wherever you're uploading it, I would suggest you go to that folder and copy the name. So it was this Detroit 1536. Okay, copy that name. And I don't know, some people like to use notes. I very often just use Word when I do this kind of stuff, just pasting stuff inside here. And it's a .jpeg. And then the same for the pattern. So where's the patterns? Here's the patterns, MDC pattern 14, I think it was, yeah. So copy that name, go to, again, either your node or using Word for this, .jpeg. So this is going to come in handy in a minute. So once all of this is in, we can start creating a job. So this is basically right now, we just made all the preparations necessary to run the code. What it does is basically that the DGG file is going to connect to the model zoo, not to the model zoo, to the GitHub repository and call the Python code from there to run it on Paperspace. So if you go back to the on the left side, and you hover over gradient, yeah, you will see that it says projects, notebooks, jobs, data, models, deployments, private clusters, and docs. And our next step after setting up the notebooks and uploading the files to our storage in Paperspace, we're gonna start a job. That's where the fun starts. So let's go, just click on jobs. Yeah, and you see already have like a bunch of jobs here from different things that I tried before, and also from the other people in this group. I see there's a bunch of failed ones, which is it's a pity. We're gonna try to avoid having fails, but there's always like very little things that can actually crash your job. One typo in the code, one space missing in the code, all of that can just produce a failed job. Yeah. So we're gonna try. Oh, let me go back one more time to the jobs here. So these are the jobs that already ran. And very often it's useful to have those jobs around, because quite often you're using the same technique, but just want to use different images, for example. So if you have already a successful 2D to 2D style transfer job done, the only thing you need to do is clone that job, yeah? And it's gonna clone everything. And then you go into the code, change a little bit, for example, which images you're using, and run the job again. And chances are that it's gonna work, yeah? If you want to run a job for the first time, you go here on the right side to the Try the Job Builder button. And let me just point it out quickly here. Here. Yeah. This is the Try Job Builder. So we're going to click on the Job Builder. And first, we choose a machine. I think that should be fine. Don't need to do anything here. What is this here? Oh, that's fine. Okay, let's go. This works anyways. So the machine is fine. And then this is where it becomes interesting. Okay, when I clicked here on file style transfer, it started to give me some containers and stuff here, which I don't really need that, yeah? Because we're gonna copy all of these from our GitHub repository. Yeah, so we don't have to start coding from scratch here. What goes in there, we can really copy paste stuff from the GitHub, which makes everything a little bit easier. So let's go back to the GitHub repository here. You remember that we went to neural style transfer, and this is basically the tutorial for the 2D style transfer. And when you run the 2D style transfer, like first thing we need to do, which we did already, was to install the VGG file. And now in GitHub, GitHub and Paperspace need to be connected, and to do so, we need to define some things here. First of all, the 2D style transfer Docker container image, yeah, the container. So just go ahead, copy this line here, yeah. Copy. You need to copy this line, okay? Good. Sorry, this is going to be now a little bit going back and forth between GitHub and Paperspace, so I have to jump with the sharing of the screen. So I'm going to stop sharing again and now go back to the Paperspace screen, right? Do you see Paperspace? Okay, now we copied that container from the GitHub repository. I'm going to erase this one here. You might have this line anyways empty, yeah? And paste our GitHub repository here, the container, the Docker, yeah? It goes in here. Now, next one is the workspace. Stop sharing here again, go back to the GitHub. And you see here, workspace, right? Copy this workspace here. Yeah. Copy this one. And then we go back Paperspace, and here's the workspace reference. We're going to paste that workspace in here. Stop this again. Go back. GitHub. And now this becomes a bit interesting here, because now we are discussing the command format with running with no mask. You can also run these codes with masks, which would allow you to only influence images partially. But right now, we're just going to focus on the full image. If you like, you can try out with a mask and so on. It's completely up to you. But I'm gonna, and all what I'm showing you, you can translate to any one of the depositories that we have or the code that we have. The concept is always the same. So the command format, yeah, like how that code is running, is basically that it's a bash run. Bash run is basically a collection of code and commands that are addressed at once, instead of having them, instead of having to create a series of commands. The bash combines a variety of commands at once. So it's a bash run of the 2D neural style transfer underscore no mask sh. So this is basically the Python code. And then whatever is here in large letters, that's basically just an instruction of what's happening here, right? So we have a content file, yeah, which would be the target of what we're trying to do here. A content file that is in the style folder, yeah, and that would be file output directory, yeah. That would be what it is, yeah. This in the next line, this is a little bit more complicated, yeah. Not complicated. It's just basically saying, here is your target file, here's your style file, and in the next couple of commands is what are you doing with it? That's what's happening here. Yeah. So you have one content file, one style file, yeah, and the output directory. So where does it go? Basically, so you have one content file, one style file, and the output directory where it's going. And then the next one is the image size. So you can control how large it's going to be your result. And then you have 3 numbers that define, which you can tweak. Yeah? So these are the weights. So you have the content weight, like how much is the content being influenced. There's the style weight, how much is the style being influenced or influencing. And then the number of iterations. And you will see that this is something that is absolutely a question of fine tuning. Yeah, how much the target image is getting influenced by the style and vice versa. Okay. This is the number of iterations. And then the next line here, command example for running with no mask. This is something that we're going to take and we're going to copy it. Yeah, because it's doing exactly what's described on the line before. So it's bash running a 2D neural style transfer with no mask Python file. And it's defining where's the storage of the models. Yes, we have a little bit of a different storage here. I'm going to change that in the code because we are just, our storage is not the 2D models. Our storage is the styles where we have the pictures. Remember, we uploaded the images to the styles folder. So it's not the 2D models. And then it defines the robotics building satellite image as the content file. And then the storage again for the style file, yeah? And it goes to the artifacts folder, the result. We're gonna see in a minute what that is. And here you see the weight of the content, the weight of the style. Oh no, sorry, 500 is the size. 500 is the pixel size of the final image, yeah, sorry. 5 is the content, 1 is the style, and 100 is the iterations. Okay, let's copy this file here. Let's copy this line. Okay. And I'm gonna go back to Paperspace. And I'm gonna paste it in here. Paste. All right, good. So bash run, 2D neural style transfer, no mask, and the storage is a bit different here. So the storage, first of all, I'm going to change this here, styles. That's the folder where we have it. And maybe you remember before that I copied the name of the images to a Word file. Yeah, remember? And that's what I needed it for. I'm going to take this now and say that the Detroit image is the content. No, wait, sorry, other way around. The MDC pattern is the content. Okay. So you're going to go storage styles, and then I'm going to paste in here that image name. So there it is. Storage styles MDC underscore pattern and underscore 14 JPEG. That would be the content file. And then the next part of the code is storage. And then we're going to change also this one here, styles. Yeah, because that's the folder where I copied the file to. And now I'm going to copy the Detroit file name here. And you have to be careful not to copy it with additional spaces or anything like that, because that really can mess it up. Okay. So I think I copied it with one additional space, but doesn't matter. I can delete it here. So go back to the code. So now we have storage /styles/ and there we're gonna go and put our content. Well, check. There is one space after PNG here. Yeah, so we can leave that space and just. So that should be fine. There's one space here, that's fine. And then you go to artifacts. That's where the file is going to be copied to. And 500, I would actually do this 512. And then the weight of the content, the weight of the style, and the iterations. And I'm going to leave this for now like this, but I would recommend to you that when you are trying to, for example, replicating this one command or this one job, if you rerun this job, you can start experimenting with, for example, swapping what is the content file, what is the style file, really going very high up with your numbers in the weights, yeah, in the content weight and the style weight and the number of iterations. All of this is quite makes a lot of a difference. I have in the meantime I almost have like a standard that I do for the weights, which is 100, 1 and 1000. This is like the standard for me to start working with, but I'm gonna leave it for now with these weights that are recommended by what we have in our GitHub. Okay. So once the command is finished, is there anything else we need to put in here? Let's see the ports, the custom metrics. See what does GitHub say about this? Okay, it should be actually fine. We are here. All right. Not entirely sure why it does not let me run it now right away. Submit the job. Should be good. Ah, all right. Yes, I know why. We have to choose still a machine here in the very top. Yeah, where it says choose machine. And I'm gonna go for the P4000, which is already what I have running. Yeah. Okay, now it actually has the machine. And now it should be fine. It should be ready to go. Yes, now we have a green button. So now actually I can go and submit the job. Did you all follow? Was it too fast? You got it? Okay, so I'm gonna submit the job now. And when it submits the job, it actually shows you in the gradient job runner, yeah, where that is. So I can see my machine here now in the top, and it says it's pending. Yeah. I have to say that very often, if you have a failure of the job, most of the time it means something's wrong in the code. Either you have a typo, you have a space somewhere too much, you copied the wrong. Here you see you have an error already. It's me. Okay, I have an error right away. What could that be? Let me just quickly check in my notebooks whether this is the right code. Is my machine here? So I'm gonna open this. Yes, see, it was not running. My machine was not running. Yeah. So if my machine is not running, it cannot run a job. It's very clear. So I'm gonna restart that machine. Yeah. Open notebooks. Yes, you see, it's turned off, stopped. So it cannot run anything if it's stopped, right? So let's start this again. Chances are that I cannot start it now, but I'm gonna try. So once the machine is again up and running, I can go back to the jobs, basically clone the code that I made, yeah, and rerun the job. For you to have an easier time, it's also very useful to name the jobs, yeah. Like with anything else in computational design, naming things is sacred and important because it makes your life just easier when you have to find new stuff. Was anyone successful? Let's see, I can actually see if somebody of you was successful in running a job so far. No, they're all running. By the way, chances are also when a lot of people are running jobs simultaneously that we run out of machines. As mentioned before, there is not an endless amount of machines that can be running. So we have to just wait or select another machine to run the job. So my machine is still provisioned. Wait one more time. I'm actually a bit surprised that my machine shut down because I put it to 2 hours and suddenly it just shut down. Not exactly sure why that happened.
I think
might be because, yes?
When you looked at an image and then you wanted to go back, you click the pause button at the top right before clicking the back button. And that stopped your notebook.
Thanks.
So my machine was still running and I still got an error and it's saying downloading files from one of the GitHub directories could not be resolved.
Interesting. That is interesting. What we can try, I mean, for sure, I have a bunch of jobs that were successful in 2D to 2D. What I do very often is I just go back to the ones that are successful and copy paste the code. So I could go to one of mine that worked and I can copy paste it onto the chat and you can just try by only changing the images and see if that one works for you. Because they were running anyways already. But I'm curious, I would like to run my job and see if it really is unsuccessful. But in the meantime, what I'm gonna do is I'm gonna go to my jobs and copy the code that I have from an older job into the chat. And Rosa, you could actually just try it out and see if a problem emerges. Because if a problem emerges between Paperspace and GitHub, then there's another deeper problem that we probably have to tackle. Yeah. And they work.
Yeah, I made a few a week and a half ago or something.
Okay.
Yeah, I have them.
I was just wondering because actually I have to go to my private account to copy these files and it might be a little bit complicated. So I was wondering whether just to copy yours. If that's okay.
Yeah, that should be.
Okay, so what I'm gonna do, and you're seeing anyways my screen, you see there is one 2D neural style transfer thing here from Kale. Thanks a lot for sharing. And if you see under success here, there is something called rerun. Yeah, rerun. When you click on that rerun, it allows you to clone the job. I'm just gonna say 2D test. Thanks, Kale. Running again the same machine, and the job command is here. And here's actually where you, when you're rerunning the job, is where you can start changing the files. So if I have storage styles, and that's again where I want to use the Detroit and pattern thing. So the MDC pattern is the content. Okay. And I'm gonna put it here where it says styles, Euro PNG. That's where I'm gonna paste in now pattern. And then the Detroit image, copy. Storage. Oh, wait a second. Yes. Okay. Again, one more time. MDC pattern goes into the first one. And then the Detroit image is the style. And I'm gonna do a rather, oh. Here. And it goes into the artifacts folder. I'm gonna do the image a little bit smaller with 512, and I'm gonna stay here with 100. Or 500. There's also the possibility that sometimes these jobs crash or don't work because it didn't like the weights. That also occasionally happens. Yeah. Let's rerun this job. That's the basics of it. You have to go into the GitHub repository, select the neural network you want to use, go through the tutorial that explains exactly how that code, small line of code works. Yeah. You don't need to have much more coding knowledge than that to know where you're depositing your files and how basically the directory of the files look like. And that's about it. Yeah. Do you have any questions? So your homework basically, yeah, is based on this that you just learned and just saw. And what I want you to do is use one of your own images from whatever you've been creating throughout being a student at top in college, yeah, as the content image, yeah, and then use an image from architecture history that can be a facade, that can be a, can be a top view, can be a satellite view, yeah, it can be an axonometric or a perspective view. It can be an interior, yeah, it's up to you, but a historic image. And what I mean by that is an image done before 1900, yeah. So not something that is recent or new, but rather something historic. Because what we're trying to experiment around here is tapping into the history of the discipline in order and combine it with your own sensibility as designer to see in what it results. This goes back to the whole lecture that we saw today artificial intelligence and art, and basically experimenting with understanding historic imagery and how that starts to create this visual indeterminacy that we discussed in the lecture in an architectural context. Okay. You can also experiment more around if you like. You can, for example, experiment with having two images from history that create one output, and then using that one again as a style that is combined with one of your own images. One of your own things that you did so far as architect and designer. So it's really this conversation between what kind of sensibility does an AI develop through style transfer, and how you can infuse that indeterminacy within your own sensibility as designer. Okay, do you understand? That's the task for next week. You can create as many images as you like. Yeah, I will try to solve what's going on here. This should work really fairly soon. Yeah, don't worry too much. But the way how it runs is how we did it today in this workshop. Any questions?
So is that just we run the job and we change the two images to the same name as our own images, then run the job, then it will create that image? Am I understanding?
So I think you need to experiment a little bit around with it to get it right. It's basically combining your own image, like take a rendering or a photograph of a model that you made, or a painting that you made, or a drawing that you made, yeah? And that could be the style image, yeah? And then you take a content image, which is a historic image, like a drawing from a facade from the 18th century, or an interior from the Renaissance, or an interior from Gothic time, yeah, or the exterior of a Gothic cathedral. So you take these two images and you create a style transfer between the two, which will combine, for example, Gothic sensibilities with your own. Do you understand what I mean by that? Because the resulting image is this kind of weird combination between the two. That's why style transfer actually is so interesting. And one thing I need to show you nonetheless, I'm going to switch to my own account to show you that with the jobs that actually worked. So for example, here I have one job that worked. Are you still seeing the Paperspace? Yes, okay. Now, when you here between, well, I may just point it out with an annotation tool. Here, you see this colored little icon here? Yeah. Okay, that colored little icon is quite important, because if you click on it, this one here, you click on it, you actually can go to the, first of all, it shows you what happened in the code, which is super interesting when you need to debug stuff. Yeah. But more importantly for us now, one of those tabs up here is called artifacts. Yeah. And you click on that artifact, it actually contains the resulting image. That's where you download the result. It's a bit hidden away, yeah, but that's exactly where you can take this image and then download it, and it will give you that full scale. I mean, this is like 1,536 by 1,536 pixels, yeah, and it will give you that result of the process. Because I mean, I didn't explain to you where the artifact folder actually is, where you have to download your results. You could have looked for it, I think, for a long time. Anyways, that's where you get it, yeah. And you just basically, you can save the image as, and then it will save the image as a PNG file, okay? All right. This concludes basically our session for today. I'm sorry, I went a little bit over time. All right, so think about what we discussed today. Think about it about the lecture. Next week, I would like to have a little conversation about what you saw today. I know it needs a bit of time to sink in. I'm going to share with you the links to the lecture and to the tutorial videos. Hopefully, it might take like 2-3 days. I admit this is not going to be immediately. Yeah. Yeah, and we take it from there. Okay. Cool. Then looking forward to see you next week. Bye, guys.